Hi, this video is addressing Ceave Gaming's Why This Mario Maker level will never be beaten. It is in no way meant to disparage Ceave, but some of the math was incorrect, and this is to fix it. If Ceave, you're watching this, no hard feelings. I have genuine admiration for your channel. I've been watching it for almost 9 years now, but there was some inaccuracies in the math that I have found a way to fix. Here I've got the spreadsheet that goes over the various steps that I did to find the actual numbers, and let's get into it. So starting off, we have Ceave's math in the video for the size of the chamber and the predictions that of numbers of like Goomba spaces there are. And what he does is he multiplies the width and height to get the area, and then takes it to the power of the number of Goombas. Now there's a few issues with this, because this is not the actual number of combinations of Goombas. In reality, it's far smaller. The lock of well-kept Ceavecret, whilst still pretty much impossible by the end of this, is significantly easier to crack than the video would have you believe. Here, let's do a simple example to show why Ceave's lock may be inaccurate. Here we've got a grid with a 4 and a height of 2, and let's decide to plot in 2 Goombas. Now, Ceave's prediction would say there's an area of 8, there are 2 Goombas, 8 to the 2, 64 possible combinations. Also, this video is being rushed out, you can probably tell. I don't have a script here, I'm just going off of memory, but it doesn't need to be. This is just, I hope Ceave sees it and is like, oh, that's interesting. So here we've got the actual combinations, where basically there are 2 issues that this factors in with Ceave's prediction. So Goombas bounce off of each other. They cannot exist in the same, well, they can't exist in the same space at once, but they try not to. So while there are 8 possible places that the first Goomba could be, because it's filling up one of them, there are only 7 combinations of spaces that the other Goomba could be. So instead of 8 times 8, it would be 8 times 7, which is, this is permutation, which is a combinatorics function that figures that out, but basically what this is just doing is it's taking 8 times 7, and if there was a third Goomba, it would do it by times 6. But there's another thing. The exact positions of the Goombas don't matter. When the on-off blocks turn on, killing the Goombas, it doesn't matter which Goomba it kills. It will kill any Goomba, which means that fundamentally, Goomba A being here and Goomba B being here is no different than Goomba B being here and Goomba A being here. So, because there's 2 combinations of Goombas A and B, you divide by 2 to get the number of 28, which is the actual value for this simple 4 by 2 with 2 Goombas example. And if you added a third Goomba, you can see the function here we're using is factorial, because the first Goomba can go in any of the 3 spaces, the second can go in 2 of the unoccupied spaces, the third only has one choice, 3 times 2 times 1, which is what a factorial is. So you divide the new number that factors in spaces being occupied by the factorial of the number of Goombas. So, if we go to the real thing, you can see that the Ceave prediction of 10 to the 45, once you factor in that the Goombas can't be in the same space as each other, becomes 3 to the 45, and then once you divide by 18 factorial, gives you only 10 to the 29. Now this is still a ridiculous number, but it's 10 to the 15 smaller. And how does this affect the math? Well, in his initial video, he takes the number of inputs, 2 to the 165, and divides it by a trillion and then converts it to days, so a trillion a second. But there's issues that, well, there's issues that he's not factoring into this, because he brings up hash collisions earlier in the video, but there's hash collisions here. there are only, according to Ceave's prediction, let's ignore this for now. According to Ceave's prediction, there are 10 to the 45 possible combinations for the Goombas to be in the chamber. And there's 10 to the 49 inputs, which means that every single combination of Goombas in the chamber will have 9,000-ish, 10,000-ish inputs that result in it. So you divide the time also by 9,000. But this isn't the actual number of combinations of Goombas. The actual number is this. So if you factor in hash collisions, and there ends up being basically 10 to the 20 hash collisions per input. And then once you divide by 10 to the 20, you can see that while this number is actually still huge, it's 5.5 trillion, which is still never going to happen. The lock takes far less time to break than the video would lead you to believe. Not that Ceave did this maliciously. It's just it's about 10 to the 20 quicker to do than it actually seems. Which, I mean, if you had like something where it was quintillion per second. No, quintillion per second isn't even enough. Sextillion per second, you could actually end up doing that in real life. So it's not entirely unfeasible to imagine the Mario Maker community actually finding a way to brute force locks like this.